So you might remember on Friday we played this game, and the game was pretty straightforward. I mean, the premise was I gave you a parent function, and then after I told you what the parent function was, I also gave you a list of directions. Or in other words, I told you how that function was going to be transformed. So for instance, this one here, which was our practice round, says that the parent function is translated 3 units to the right, reflected vertically over the x-axis, and then vertically stretched by a factor of 4. And your goal was to take that information and to write the function equation over on your whiteboard. And so this one here ended up being f of x equals negative 4 times x minus 3 squared. And of course that's because it needs to be translated to the right 3 units, reflected vertically, and stretched vertically by a factor of 4. Now, one of the things that you and I have talked about many times is mathematicians tend to hate descriptions like this. Or in other words, mathematicians hate when things take longer than is necessary. For instance, these words over here on the right-hand side of the page, it's just way too much information when you could relay or communicate information in a much more efficient way. So what mathematicians have done is they've taken those paragraphs and they've turned them into little cheats or little codes that need to be followed, and they're kind of written in their own language. Today, our goal is to determine what is that short, quick, concise language that they use, and what does it tell us? So first, just keep in mind on the right-hand side, there was that nice big paragraph, 3 units to the right, reflected vertically over the x-axis, and vertically stretched by a factor of 4. And mathematicians, though, they would not do that. Here's what they would do. They would say, hey, the parent function is quadratic, and here is the transformation that it follows. Using that transformation, can you determine what the function would be? So you might notice over here, this is a code that tells us we would like the function to be moved right 3 and vertically reflected and also vertically stretched by a factor of 4. It's quick, concise, clear, and there are no words here. It's right to the point. You'll also notice that there's an f here because that's implying that our function will be named f of x. You also might notice that there is purposefully no square or no exponent of 2. That's because these rules or these cheat codes can be applied to any type of parent function, as long as you also know what the parent function is to start. So for instance, this is the parent quadratic. It follows a rule of 3 to the right, vertical flip, vertical stretch of 4, and so you would get this function here. I know this might be a little confusing because we've taken all of the words, all of the descriptions, all of the bullet points out of it, so I thought you might like to see a couple more examples. So here's just some quick fire examples for you. So first, let's say your parent function was the square root and you were given a direction or a set of directions that looked like this. You'll notice this is not a paragraph of directions. This is not a bullet point list of directions. It's just a clear, concise rule that we have to follow. We know we want the function to be named f, and we know that we want the function to show a horizontal shrink factor 1/2. And I know that because this is inside the grouping symbol, and it's a b value. So that means our function would end up looking like this. F of x equals the square root of 2 to the x, the square root of 2x. The 2 is inside, which shows a horizontal movement, and the function is named f of x, and it is the square root function. Here's another one. We want to start with the parent function power exponential, and we'd like to follow a set of directions to transform it. The directions are f of x minus 5. This is telling us that we want to take the power function, the parent power function, and move it down 5 spaces. You might notice this minus 5 here is commonly referred to as the d value. It's located where the d value would normally be located, and it's also outside of the grouping symbol. We want the function to be named f, and so this would end up being f of x equals 2 to the x, take away 5. Again, a vertical translation, down 5. Another one. The cubic function is the parent. Our set of directions is not a long list of reflections and dilations, stretches, shrinks. It's just a simple, concise, clear rule. We want the function to be moved to the left 1 unit, and we want it to be vertically flipped and also vertically stretched. And that would create this unit here. This function here. F of x equals negative 3 times x plus 1 to the 3rd power. And finally, here's a last example. If we have a parent function that's the absolute value, and we want to know how it's transformed, this one here is going to be to the right 1 unit. It's going to be flipped horizontally. It's going to be named f. It's going to be stretched vertically by a factor of 4, and it's going to be translated up 3 units. And that would, of course, create this equation here. This is the absolute value function. It is moved right 1, reflected horizontally, stretched vertically by a factor of 4, and also moved up 3 units. So again, this isn't necessarily anything new. It's just presenting or communicating a different way to ask for transformations. It's clear, it's concise, and it's much shorter. So mathematicians love it because it doesn't involve a lot of words.